again, and welcome back to part two of the three-part series I got going on the different cycles that our body has in biochemistry. Um, First, I started off with the glycolysis pathway, starting from my journey as a young glucose to a fully grown pyruvate here, living in my pyruvate residence. And now, I'm going to talk about how pyruvate undergoes the Krebs cycle or the citric acid cycle, and I'm going to do that with my noble steed here. So we start off on mitochondrial way as pyruvate enters the mitochondrial matrix. Before pyruvate enters the Krebs cycle, though, it needs to become acetyl-CoA, and to do that, it undergoes it encounters pyruvate dehydrogenase complex, turning it from pyruvate to acetyl-CoA. After that, acetyl-CoA comes into contact with citrate synthase along with oxaloacetate, and through this condensation reaction becomes citrate. And mind you, this is a one-way cycle, so one-way street, we go this way. Citrate comes into contact with aconitase, which undergoes an isomeration to become isocitrate. This reaction can go both ways, but more so favored toward moving this way. After this, isocitrate comes into contact with isocitrate dehydrogenase, and through a decarboxylation becomes alpha ketoglutarate while spending a carbon dioxide along with an NADH molecule. After this, it undergoes a decarboxylation through alpha ketoglutarate dehydrogenase complex and becomes succinyl-CoA, while also getting rid of an NADH and a CO2. CO2 kind of just goes here. And then I made these little things over here to kind of coincide how NADH and FADH down there interacts with the electron transport chain. They both kind of donate a hydrogen, but that'll be in the next video. Moving down, we have succinyl-CoA synthetase, which turns succinyl-CoA into succinate with inexpensive ATP right here. After that, we encounter succinate dehydrogenase, which is an oxidation reaction and turns succinate into fumarate with the expensive FADH2, and that gets sent to the electron transport chain. Moving down the road once more, fumarate comes into contact with fumarase, turning it into malate at this point in time. And finally, we run into malate dehydrogenase, which is an oxidation reaction, turning malate back into oxaloacetate, and thus beginning the cycle once more when coming into contact with acetyl-CoA and aconitase once again. And that is the citric acid cycle. This can both be a catabolic or anabolic reaction, which is considered amphibolic, and this can yield 2 carbon dioxides, 3 NADH, 1 FADH, and 1 ATP. And yeah, that would be the citric acid cycle. Stay tuned for part 3 when I explain the electron transport chain.